Our exit ticket out of this section was going to look at how we can multiply some radicals and then, if necessary, simplify those. So we're going to have to remember some of the rules we've been learning throughout this session. Square root of 15 times the square root of 3. I can multiply the insides because I have the same index. They're both square roots. So 15 times a 3 becomes a 45. Then, can I simplify 45? Or the square root of 45? Well, it depends. Are there factors of 45 that are perfect squares? And if so, can I find the highest one? Well, this does reduce down to, or factors to, a 9 times a 5. 9 is a perfect square, and it's the highest perfect square I can find that's a factor of 45. Square root of 9 is a 3, and then the square root of 5 just remains square root of 5. So simplified form then is 3 times the square root of 5, or 3 square root of 5. Another example. 7 cube root of 4 times 5 cube root of 6. What do we do? Well, a couple things we need to understand before we begin. We're in cube root world. Both of them are cube roots. So then I can do an operation. So how do I multiply these? Well, we multiply the 7 times the 5 first just to get it out of the way. 7 times 5 is a 35. Then I can multiply the roots. Cube root of 4 times the cube root of 6. That becomes a cube root of 4 times the 6, which is a 24. Try to simplify if possible. Since I'm in cube root world, I need to think about factors that are perfect cubes. So what's a factor of 24 that's a perfect cubed? I think 8 as well. So let's rewrite this. So I have 35 times the cube root of 8 times 3. The cube root of 8, I can reduce that down. I'll even do one more step in here just to try to make it very clear. So this can become the cube root of 8 times the cube root of 3. So I get my 35, cube root of 8 is a 2, times the cube root of 3. And then 35 times 2, I can multiply that, and that becomes 70 cube roots 3. And there's my multiplication and its simplification. Lastly, I have the fourth root. I don't know how much room I'll need for this. The fourth root of 8x cubed y squared. Multiply that also by the fourth root, which means I'm able to multiply 8x to the fifth times y to the cubed. What do we do, folks? What do you guys want to do? Well, I understand that I have fourth roots. I need to be thinking about numbers that are perfect fourths. So the first thing is I can multiply these together because they're part of the same roots. So I now have the fourth root. Lose an ink on my pen there. 8 times 8 is 64. X to the third times x to the fifth is x to the eighth. Y squared times y cubed. Add the exponents. I get y to the fifth. I know every now and then we want to make that y to the sixth. We're multiplying. Do we multiply the exponents? No, no, no. We add the exponents. That's going to trip us up if it already has it. Let's rewrite this then into perfect fourths. 32, the factor, 2, 8, no, perfect 64, my numbers. I don't know what my perfect fourth numbers are. So 1 to the fourth is 1. 2 to the fourth is 2 times 2 is 4 times 8 is that's 16. 3 to the fourth, that's 3 times 9. 9 times 27, looks like it's 81. So are any of those numbers factors of 64? I think 16 is. So I'm going to rewrite this as 16 times a 4. That makes 64, and 16's a perfect fourth. X to the 8th, that's already a perfect fourth. And then the y, I'm going to make that as y to the 4th times y. So I factored each of the terms into factors that include the highest perfect fourth I could find. My result then is the fourth root of 16, that's a 2. The fourth root of 4 is a fourth root of 4. The fourth root of x to the 8th is x squared. X squared times itself 4 times produces x to the 8th. There's no more x's. The fourth root of y to the 4th is just a y, and the fourth root of y is the fourth root of y. So my final solution is 2x squared y, fourth root of 4y.